All right. Now, chapter 9, the last chapter we're going to cover. Chapter 9 is talking about derivatives. Derivatives. In this chapter, we are not going to cover everything in this chapter, particularly the first two sections, section 9.1 and 9.2, we are not going to cover because it's talking about mathematics or calculus in particular, talking about limits. We only have a simple meaning of limits that we're going to use, and I would explain it once we get there, right? So these are the topics: limits and continuity, which is the first two sections. Then the next section, 9.3, which is what we're going to do, 9.3, talking about derivatives, right? The rules of differentiation, that would be 9.4. Differentiation of exponential and log functions, actually 9.4 and 9.5. And that's what we're going to stop. These two is what we're going to cover. 9.3, 9.4, 9.5. Differentiation of exponential and log functions is something more advanced in calculus, which we are not gonna deal with. So we're gonna skip. Let me end this show and skip these first two section slides, which is 9.1 and 9.2, and let's actually start here. This is the end of 9.2, I think. Rates of change. Rates of change, because that's what basically derivative is rates of change. Average rate of change or of a function f over the interval x and x plus h. Again, that's the x value and that's the y value, right? The way you calculate the average rate of change is f of x plus h minus f of x divided by h, right? What does that mean? That means you evaluate your function, whatever the function is, and we're going to do that. We're going to solve a problem like that. You evaluate your function at x plus h, and from that you subtract the function itself and then divide it by h. When you do that, you get the average rate of change, right? Average rate of change. That is called the slope of the secant line. That is the slope of a secant line. Okay, let me show this graphically, and maybe it would become a little bit clearer what we are talking about. Let's say here is x, here is y. Let's say we have a quadratic function, and this quadratic function is going to give us a curve, an upside down U-shaped curve like this, right? If you take 2 points on this, point A and point B, point A and point B. If you connect these 2 points together and continue, this line that connects 2 points on a curve, wherever the 2 points are, that is called the secant line. So this is the secant line. The slope of this secant line is what we are interested in. Okay? How do we find the slope of any line? The slope is rise over run. Slope is rise over run, right? In this case, rise is measured vertically on the y-axis, such as change in y, and run is measured horizontally over the x-axis, so that is change in y over change in x. So if I can find where y changes and where x changes, I can get the slope of this secant line. So what we're going to say is point A has the coordinates of x, and f of x, whatever x value is, and point B, which is h, this distance is h, difference, so that would be x plus h, right? It's just h value above x, and the y value would be f of x plus h, whatever that number is. So clearly, if I want to figure out rise over run, I will do this. Now from here to here is a change in y. From here to here is a change in x. Now what is a change in y? It goes from f of x to f of x plus h. So the change in y is the difference between these two. So this would be equal to, change in y would be the difference between these two, whatever this number is minus whatever this number is. So it would be f of x plus h minus f of x. That's the difference between these 2 points. That's the change in y. And change in x is the difference between x plus h and x. So x plus h minus x. So when you do that, minus x and plus x will disappear. Therefore, you're left with f of x plus h minus f of x in the numerator and h in the denominator. And that's what this one is showing. This is the slope of the secant line. This is the slope of a secant line. Okay, so if you take any 2 points on a curve and connect them together, that is a secant line. And the slope of that secant line shows the average rate of change between the 2 points. The average rate of change between the 2 points. Right? Now, let's go back to the picture. If you hold point A constant and bring point B closer to point A, bring it to here and then have a secant line, bring it to here and another secant line, bring it to here, and so on and so forth. What is happening is every time you move point B and bring it closer to point A, right, your x plus h would get closer to x, would get to h. So what is happening is h is getting smaller. Every time you move from point A or move point A closer to h, closer to A, h is getting smaller. You keep doing that and push h towards 0. Push the difference between this point and this point, bring it this way to make h as small as possible. Make h smaller. That means driving h towards 0. So when you do that, the slope of the secant line would become really the slope of a tangent line at point A. So as h is driven to 0, as h is getting smaller or driven to 0, then the secant line would become a tangent line. And the slope of a secant line would become the slope of a tangent line. Right? And that's, you say, the instantaneous rate of change. Instantaneous rate of change. So instantaneous rate of change is the limit of this, the slope of a tangent line, which is f of x plus h minus f of x divided by h, as h is driven towards 0. That would be the instantaneous rate of change. And that, by the way, would be the derivative of the function. So when we talk about derivative of a function, that is the slope of a tangent line at any point x. So the slope of a tangent line is what we are calculating when we are calculating the derivative. So we understand what the secant line is. Secant line is connecting any 2 points on a curve, right? One point is x, the other one is x plus h. So the 2 points are away from each other by h unit. That's the difference between the 2 points. And the second step is bring the second point closer to the first point. That means from secant line, now you go toward the tangent line. Let's see what we got here. Instantaneous rate of change. So we know the slope of secant line already. The instantaneous rate of change, as I said, you take the limit of the slope of a tangent line. So here is the first one. The first one is the slope of a secant line, and this is the slope of a tangent line. Right? When we see the example, it will become clearer. Now, basically, now we're going to 9.3. Derivative of a function with respect to x is shown by f prime. So when you see a prime, that means derivative. How do you calculate the derivative? Look here. F prime of x is equal to limit of f of x minus f of x plus h minus f of x divided by h, as h is driven to 0. Well, you remember, this was what? This was the slope of a tangent line. So derivative of a function is the same as the slope of a tangent line. Right? And that's how you calculate it. It is called f prime of x. This is f prime of x. Okay? By the way, this is also, it can also be written, instead of f prime of x, it can also be written dx of f of x. Okay? Derivative with respect to x of f of x, your function. Okay? Also, if your function is y equals something, this can be written as y prime. So different notations you have for derivative. F prime of x, y prime, or d divided by d of x of f of x. 4-step process in finding f prime. Number 1, compute f of x plus h. Again, this is what you have in the formula. That's what the steps are going. Compute f of x plus h. From that, subtract f of x. And then divide it by h. And then take the limit and drive h to 0. Those are the 4 steps. That's all it is. Compute f of x plus h. Number 2. Form f of x plus h minus f of x. That completes the numerator. Divided by h. F of x plus h minus f of x divided by h. And finally, compute the limit as h is driven to 0 of the step 3. Whatever you did, whatever you come up with in step 3. Okay? Those are the steps. Now, here is a simple one. Find f prime of x. Here's f of x. You want to find f prime. This is f of x. So what was the first step? Step number 1, find f of h plus h. F of h plus h, that means in place of x, you put h plus h. So it would be 2 times h plus h squared minus 1. Now 2, expand h plus h squared. That would be what? H squared plus 2xh plus h squared minus 1. And finally, it would be f of x minus h. It would be equal to 2h squared plus 4xh plus 2h squared minus 1. That's step 1. Step 2, it says f of x plus h minus f of x. So f of x plus h is this, 2h squared plus 4xh plus 2h squared minus 1, that's f of x plus h, minus f of x. F of x is this one up here, the original function. So minus 2h squared minus 1 equal 2x squared plus 4xh plus 2h squared minus 1, and now minus 2h squared plus 1. You can see that terms with no h in them should cancel, and this always happens, by the way. 2h squared here minus 2h squared minus 1 plus 1, they cancel. Therefore, this f of x plus h minus f of x would now be simply 4xh plus 2h squared. Step number 3, divide f of x plus h minus f of x divided by h. So that is 4xh plus 2h squared divided by h. That would be, factor out h in the numerator, 4x plus 2h divided by h. Now this h and this h would cancel. Therefore, that would be equal to 4x plus 2h. Step number 4. Now find the limit of f of x plus h minus f of x divided by h and drive h to 0. Well, this one here, I already found it, is 4h plus 2h. So it's the limit as h is driven to 0 of 4x plus 2h. Now, when h is driven to 0, right, it would not impact the 4x. There is no h involved here, so the 4x would remain. But when h is driven 0, 2 times h. As h gets smaller and smaller, the twice that smaller number would be driven towards 0. So 4h, 2h would be driven to 0. So the limit of this would be only 4h. And this, by the way, is the f prime of x. Okay? So derivative of this function up here, would be equal to 4x. They should go through the same steps on the slide. We're going to see to come up with the answer as we did. F prime of x equal step 1. Step 2, subtract f of x from it. So we'll do 4h plus h. Step 3, divided by h. And step 4, find the limit. And finally, the answer is 4h, which is what we had here, by the way. There you go. Again, when h is driven to 0, this term this term will go towards 0 and will become 0 ultimately. So all that is left is only 4x. That's what this 4x is coming. This is f prime of x, 9.3 ending. This is not, forget about this one, the continuous and non-continuous, because we didn't do the first section.